Assalamu alaikum wa rahmatullahi wa barakatuh. Dear brothers and sisters, welcome to Next Gen Training Center. I'm Mr. Khairi Nuh. I'm the senior STEM educator here at the Next Gen Training Center. And today, inshallah, we are going to preview the Ev3 course outline, contents that students are going to learn throughout the course. Okay. This course is divided into 3 levels, and it depends on the timing, of course, of the schedule, but mainly like twice a week and 2 times a week. And it will be divided into 3 levels. Each level takes like 1 month or something. So what should students learn in level 1? The first thing we start with is, what is a robot? We give the students the definition, which is more like the most accurate and scientific definition for a robot. You know, they get to know everything exactly. How is a robot different from a toy I have at home? Or, you know, machines, for example, how are they different from robots, and so on. This will be the first lecture. I'm used to do that. Then we're gonna move after that to defining programming. What is programming? What is meant by programming? And then what is a flow chart? And what is logic? And this is very important, because this is where you teach the student, you know, how to think in a logical way, logical order of thinking, which is called robot thinking or logical thinking. And this is very important in students' lives. Next, we move to explain the parts of Ev3 robot, the different parts and components and the names of these parts. And next, we move to motors. How do they work? After that, we're gonna study the gears and gear ratio. Okay. And then we will explain everything about Ev3 sensors, and then talk about basic mechanical design of educators Ev3 robot. There is a simple robot which is here. You can see it here now in the image. So this robot is called the educators robot. This is the very simple and standard Ev3 robot that all students who learn Ev3 would start with. Simple design, simple programming and coding, and also includes some sensors. And then we can start from here to do more practice on programming, try different movements, try different, different games, strategies, some tasks. Okay, so that the skill of programming will be developed for students. And then let's build our first robot. Yeah, so gonna explain the basic mechanical design of the educators robot, and then we will build this one. And then we will move to Ev3 programming IDE. The program itself, we're gonna use it for programming this robot, an overview of everything about that. And by the end of this month or this level, we're gonna do the graduation project, which is let's program our first robot. Next, we will move to level 2. First, we should start with reviewing everything about level 1 content to make sure that students still remember everything, all the information, how to build a robot, how to program a robot, and everything is clear for them, because some students might come to the course to get level 1 only and then get busy by school or study or such stuff, and come later after a long time, and they will not be able to retain or recall all the needed information before moving to level 2. So after revising everything that came on level 1, then we're gonna build our educators plus robot. So this robot will be more advanced than the educators robot that we built or by the end of the level 1. The third one will be getting to know more about Ev3 sensors in depth this time, and using multiple sensors with the with the brick. Okay, Ev3 programming in depth. We're gonna go deeper, dive deeper into programming, know more techniques and better techniques, loops and switches and such stuff. It's somehow advanced more than the simple commands that we used on level 1. So next one, automation. And by automation we mean how to make the robot move autonomously or automatically or without human control. So in this step we're gonna learn how to build robots that can do or make decisions themselves, the self-making decisions. So in this level we call this automation, because the robot now can move without your control. So next we're gonna move to a basic line follower robot, and there are still some competitions that are focusing mainly on line follower robots, and it will be great if we can make one during the course so that students will get double benefit out of that. After that we're gonna move to somehow advanced line follower robot. So we're gonna make one that moves better and smoother and doesn't do many mistakes, and in this area we can direct the students to use something like the challenge simulation programs, because you will have a car, for example, and like 7 or 8 sensors, line following sensors, and then you're gonna program this car to keep following this sensor without doing without making any mistakes. So we're gonna start to build this mindset, and this is this type of thinking in students' brains before they can apply it in real life with the Ev3 robot. So this is called advanced line follower robot. We mainly use ICOL challenge map or something like that. Let's build some robot models. Okay, so by the end of level 2 students will be faster in building and dismantling robots, so why don't we build more robot models? And the graduation project will be, let's build a sumo robot, because this will be so much exciting for students to do. Okay, so after making sure everything is all right and students are able to remember and recall all the information from level 2, we're gonna move to level 3 content, which is let's build a sumo robot again, this time to remember everything, revise everything about mechanical design, structure, programming, flowcharts, everything. And then sumo robot programming flowcharts, again we said we're gonna revise this. Let's improve our robots this time. Okay, I'll think about, I ask the students to think about the robot. What you think we can do more so that we can improve this robot? And this time you ask them to give you creative ideas and new ways so that you can design the robot and make it better, make it stronger, make good programming so that you can attack the enemy better, how you can protect yourself, how to run away from the enemy if he came to catch you, and such stuff. So next we're gonna study a gyro sensor for auto navigation. So if you're gonna make auto navigation in a correct way, so we're gonna use a gyro sensor for automation, or for automation of movement, or what is called auto navigation. And then integrating more than one sensor in a robot, how to add many sensors as we can to the robot. And we're gonna talk about something called parallelism and synchronous tasks. Parallelism and synchronous tasks, how to make two things take place, or like the robot will move one of the arms and do something else together at the same time. So Bootle Sumo robot design and programming, there is a good competition, beautiful competition, and the competition is called okay, I don't remember the name now, but maybe by the end of this time I'll remember. So the Bottle Sumo robot design and programming. So this is where we're gonna work on this competition, but integrate this important part of it in our course, again to give double benefit for the students. I'm trying to remember the name of the competition, but inshallah I hope to remember the name. FLL competition overview and some mission trials. So FLL is a different competition, and this time we are not giving the training to students to play FLL or to solve all the FLL missions, because there will be 16 missions or around this number in 230 minutes. Okay, so we are not doing all the missions, but we're gonna give them a good idea about the competition and the different missions there, and we can give them training how to think about the design and the code they can make to solve some of these missions as if they were working for the FLL competition. But of course this is just like a real simulation to the competition itself. And then the graduation project will be, let's build a robot to do the FLL missions. So by the end of this level they will have like limited time in their 1 month content, so that if we have enough time we can do as much missions or do as many missions as we can. So the Bottle Sumo robot design is I remember the name of the competition, which is the RoboFest, which comes from the supported by this technological institute. I don't remember the name. Thank you so much. Bye.